Okay, everybody, I don't know if you had a chance to work through the starter. I hope you did. I'm going to make these worth extra credit points on the test. I think it's the only way I can make these worth anything without, and still be fair to the people that couldn't get in on the meeting. So to do the starter really quick, we got to factor this. It's 4 terms, so we got to factor by grouping. So the common factor to the first set of parentheses is x squared. We pull out an x squared, and what's left is x plus 1. This has to be x plus 1. To make this like that, I got to pull out a negative 4, x squared minus 4, and x plus 1. Did anybody get anything different than that? Anybody get a different answer than me? Are we all happy with that? Don't everybody answer at once. To unmute your phone or unmute your Zoom, you can push the space bar to talk. Nobody's going to talk. Is that what we all got? Because that's not the right answer. Okay, we can factor this more. This over here is the difference of 2 squares, x plus, we can square root that, x plus 2, x minus 2, and x plus 1. So that there at the bottom is the right answer. If you got that answer, or if you didn't get that answer, I want you to write a little sentence, just like you did for the starters that we've been doing every day. I'm going to have you submit a picture, just like with the starters before. You can take a picture with all of your starters. You don't have to do one per page. So you can do like 6 or 8 starters on one page, and then submit your work. So take a picture, and we're going to submit that when we do the test. Okay, if you have any questions, let me know. I realized too late. The video that I submitted was not correct. Pam's video, Mrs. Hawks' video didn't work. So I don't know if any of you had a chance to work through 9.1 or even start with it. But it is confusing. It's a hard topic. It is domain and range. You guys have all done domain and range before. I know you guys did it in the middle school, but it's not an easy thing. So let's start with domain. Domain it's 9.1. This is 9.1. Okay, so we're going to do notes just like we do in class. So if you want to write these down, I'm going to post this video to Canvas. So hopefully if it works, I'm going to post this video to Canvas just like we've been doing, so you can go back and look at it if you need to. Domain is all possible x values. Domain is all possible x values. So if you have a graph of a function, this is x and this is y. So all possible x values, it's where the graph is side to side. Okay, so if we have a function that looks like, let's say this is -2, and this is, go to 3, and we have a function that looks like this. Okay, we don't care how far up or how far down this function goes. It doesn't matter. All we want is x value. So it's not -2, but it starts at -2, but not including. So you would write that as -2 to 3 x values. Okay? And really important in a hard concept is whether or not to use this or to use this. Okay, this means including, and this is not including. I ran out of room. So this is not including. Parentheses is not including. Bracket is including. So because this circle is open, it is not including -2, but the circle is closed at 3, so it is including 3. Does anybody have any questions about that? Okay. Domain is easier than range. Range is all possible y values. So range is all possible y values. So range, again with the graph, range is up and down. It's the y values. So it's where the function exists up and down. So if we were to do that same picture that we did before, where we had this, okay, and this was -2, and this is 3, these numbers don't matter. These are x values. We don't care about that. So if this is 1, 2, 3, okay, for the y values, it's up and down. It is from 1 to 3. 1 to 3. Okay, and it's not including 1. It's a bracket for, or parenthesis for 1 and a bracket for 3. Okay, does anybody have any questions? Are we all good? Awesome. So now for kind of how it looks on the homework, it has you do. And there's a mistake on the homework. The homework version that I sent you had x values. So homework for the homework, ignore x and y intercepts. That's going to be later in the unit. So ignore x and y intercepts. We'll talk about that later. But now we need to learn how to use our calculators to graph. So I know some of you don't have calculators. So a good app for if you have a Droid. If you have a Droid, I'll show you my phone. So here's my phone. This little guy right here, the Wabbit Emu. It's Wabbit Emu. It's really, really good. It has a dumb name. I don't know why it has a dumb name, but that's its name. And it's a really good app for a TI-84, the calculators that we use in class. But it only works for Droid. If you have a Droid, you can do Wabbit Emu, and it looks exactly the same. See if you can see my screen. It looks exactly the same. That's my phone. That's not a calculator. It looks exactly the same as a TI-84. Okay, if you don't have a Droid, then iPhone, you can use Desmos. See if I have Desmos on my phone. See, Desmos is the squiggly green line thing right here. Desmos, it's not as good as Wabbit Emu because it's not what we use in class. Yeah, it's got a glare. I don't know why it's got a glare. It's not showing up. It's showing up funny. But Desmos is actually maybe better, more user-friendly than the Wabbit Emu, but it's not going to get you familiar with how to use the TI-84s, and that's what you can use in the ACT. And well, I guess you can use whichever for your test. But Wabbit Emu is a little bit better, I think. So if you have a TI-84, okay, TI-84, we're going to graph. Let's graph. So to graph, you do y equals. You push this button here, y equals. And let's do y equals, and the x button is this button right here. It's the xt theta n. You push that button, it will be x. And then let's do x squared and then minus 1. Okay? If you have a TI-84, I would put that in, get you familiar with how to use that, hit enter, and then you hit graph, and it's going to show you a picture of x squared minus 1. So the x values for this are side to side, okay, and it's confusing because if you look at the calculator, it looks like it stops here at like maybe -3 or -2.5, but this function actually goes to negative infinity and goes to positive infinity. So the graph of this, I'll draw a bigger version, looks like this-ish. Okay? This function goes to negative infinity and to positive infinity. It doesn't stop where it leaves the graph. We don't care about up or down for domain. So the domain for this function is negative infinity to positive infinity. And always parentheses for infinities. You can't have infinity. It's not a number. It's actually like a moving number. It's always growing negatively and always growing positively. So it doesn't start or stop anywhere. Then the range is maybe, I don't know, a little bit harder to visualize. Okay, range is up or down. So how to range, you always start negative. Start negative, and then go positive. So is the graph of this function down at negative infinity? So it's not down at negative infinity. It's not down here. And you guys, if you don't see that, if that's confusing to you, you need to ask questions, because a lot of people really have a hard time with whether or not the function is down here. The function is this line. This line is a graph of the function. It is where it is. So it's not down here at negative infinity. It starts right here. That's called the vertex. It starts at the vertex or the minimum of the function. So to find out where that is, we actually will do a lot of work this unit to find out where that is, but you can use your calculator. Your calculator will tell you. So there's several tools on the calculator to help you find the minimum or the vertex. So one way is you can push second, calc, and you have that screen. And look down here, it says minimum. There's minimum, and also there's a maximum option. A maximum would look like this. That would be if the function has a maximum, if the vertex is a maximum. Okay, it's not easy to see, or it is easy to see, but there's a lot of different, that's what we're going to talk about for this unit. So we have a minimum, and we need to find the minimum. So you go to minimum and you hit enter, and it says left bound and right bound. Okay, so to find the left bound, what it's doing is it wants you to say the minimum between 2 points. So we need to tell it 2 points, and we need to find the calculator will tell you the minimum between those 2 points. So if you see, I move the cursor to the left and to the right. The cursor on the screen will follow along the function. So we need to say between these 2 points. So if I move it to the left, it doesn't matter how far. I can go way over here, or I can just go barely to the left of the minimum. It doesn't matter. But we need to go to the left of the minimum and hit enter. And then we need to go to the right of the minimum. And you can see it leaves a little arrow right here that's saying the point that we've said between. So now hit enter. Now it's between those 2 arrows that it's left. And guess it wants me to kind of approximate where I think the minimum is. So the guess I put it's right around there. And hit enter. And it will give you a x value and a y value for the minimum. So the minimum in this case, the minimum is this point, and it is the x value is 0 and the y value is 1. Okay, so that is the minimum. We use the minimum to find the range. Okay, the minimum is the y value. So the minimum is actually, it's a -1. The y value, -1. That's the minimum. And then for the range, we go from, it's not down here at -infinity, it starts at -1 and goes up to, these have arrows, it goes up to infinity. Okay, and the question is, the hard part for this, to me, is do we put a bracket on -1 and do we put a parenthesis on -1? And a way to tell if it is, if you remember what our function is x squared minus 1. So x squared minus 1. And to know if we can put a bracket on that, if there's a way that this will equal, or you could put the x value. And I think that's probably the easier way. If you put the x value for that point in, okay, equals y. If you can put the x value for your ordered pair in for x. So you put that number in from the ordered pair for the minimum. 0 squared minus 1 equals y. 0 squared is 0, so then it would be y equals -1. Sometimes, like if you put a different number in there, it doesn't give you a value, or you won't get the same y value. So if you can get this to equal that, then you put a bracket. And we'll talk about some stuff later on that you can't put a bracket on. Okay, I hope you guys are all following and everything's okay, because you guys are too scared to pipe up. So if you have any questions, please let me know. We're going to work through a few more examples with working with the calculators. Some of these are kind of difficult and confusing. So let's do another example. Let's do number 1 from your homework. Number 1 is y equals 2x plus 5. So I put in 2x plus 5. That's number 1 on your homework. And we're going to graph that. Looks like that. Okay? Looks like this. Okay? A lot of people get confused with domain and range and x and y intercepts. Domain and range has nothing to do with where it crosses the x and y axes. Okay? It's not relevant to each other. So we need to find out, so these have arrows, the domain for this function is where the x values are. Okay, so this goes that way forever and that way forever. So the domain is -infinity to infinity. The range is up and down. Okay, and it goes down forever and up forever. It always starts negative and goes positive. So -infinity to infinity is the range. Okay, let's do an absolute value problem. I know that a lot of you aren't familiar with absolute value, so y equals and clear that out. And absolute value, so you want to be in the graphing the y equals screen on your calculator, and then you push math, go over to num, and it's abs. It's the first one. So I hit enter, and it will give me that bracket. So what an absolute value function is, it's actually a distance. A lot of people think it just makes it positive, and it kind of does, but that's not the right way to think about it. absolute value is a distance actually from the origin. So let's look at that for a second. If we have a number line and we have -3, the absolute value of -3 is how far from the origin is -3. So it's 1, 2, 3 units. So the absolute value of -3 is 3. So in a way it does just make it positive, but later on when you get into some of the stuff we talk about in sophomore math or junior math, you'll get confused by what that means. Because it's not always just make it positive, it's a distance. So if we want absolute value of x minus 1, and then you got to push over to get out of the absolute, and let's do minus 2. So graphing that function, that's the absolute value of x minus 1 minus 2. So we graph that and it will look like this. Okay, so we have this function. Well, we can just stay with this. So we want to know how far left or right that is. And I know some of you have a hard time with this. Yeah, let's just draw a picture. So this looks like that. And that, there are arrows there. It goes all the way, it goes from negative infinity to positive. So the domain is negative infinity to infinity. Okay, range for this one is the harder one. Okay, so we need to find the vertex of that function, or in this case, the minimum of that function. So we need to do second calc 0. And it's going to say left bound and right bound again. Let's zoom into the calculator a little bit. So we need to be left of the, so this is about where we think the minimum is. So we need to go to the left of that. It doesn't matter how much, just to the left of it some. Hit enter, go to the right of it a little bit, and hit enter again. Guess you put that on what you think is the vertex. Hit enter. Oh, what did I do? I probably did. I think I did 0. Second calc minimum. Enter. Go to the right. And the minimum, so this is a really good, it's your calculator actually does calculus. It does Taylor series to find what are the numbers, what are the outputs. So it's saying that this is 1.000, lots of zeros, 23. So that is really, really close to 1. What your calculator is doing is it's trying to figure out exactly where that point is, and it's having a hard time because of the way that your calculator figures things out. So it gets really, really close to something, and it finally starts to hurt its brain and just kicks out a number like, this is close enough, you can figure it out. When it gives you something like this, you need to recognize that is not 1.000023. That is actually the x value is 1. And the y value, 1.99998, is actually, that's -2. When it gives you a number that's very, very, very close to it, it's your calculator getting close enough and it's having a hard time computing exactly that point. Sometimes you will see numbers that will be like, well, we'll talk about that when it comes up, but you get the e's. Yeah. So that is our ordered pair for our point. Remember, the minimum is the y value. We use the y value, or in this case, -2 for the range. The range is from -2 to infinity. Okay, and then bracket or no bracket, that's when it's hard. Parentheses, or infinities always get parentheses, and then it's including that point -2, so including bracket. To figure that out exactly, we can remember what we did for our function, the absolute value of x minus 1 minus 2, and we can put in the x value, which is 1 minus 1, 1 minus 1, and the absolute value of that minus 2. 1 minus 1 is 0, absolute value is 0, which is negative 2, gives you that value. So when that happens, you can bracket your function. I don't know if you guys have any questions. You can jump in anytime. We're all terrified to talk on Zoom. So, does anybody have any questions? Okay, I don't know how many of you guys have calculators. Let's do let's do a square root function. Y equals the square root of x minus 3 minus 1. I'm going to leave that there. I'm going to wait a few minutes. I'm going to let you guys try and find the domain and range of that function. So please, you guys, those of you that are here or virtually here, try that problem. I'm going to give you a couple of minutes. Try and find the domain and range. Anybody have any luck? What'd you get, Nathan?
I don't know how to put a square root in.
Beautiful. So to put a square root, do you have a TI-84 like this?
No.
What are you using?
Desmos.
Okay. To use Desmos, let's see. I don't know. Maybe my screen's too bright. Let's try on my phone. That's too dim. Yeah, that'll work. So for Desmos, you do the functions, and then MISC, and then I think, well, maybe not. Maybe it's just, yeah, it's just right there by the ABC. You see that?
Yeah.
So you do square root of x minus 3, and then you get out of it by pushing the side arrow, and then minus 1. And
okay, thank you.
And then there's your graph. Desmos is really good because to find the minimum, all you have to do is tap on it. I don't know why it's not doing it. It's doing it for like half a second. I don't know why it's not doing it. But usually you just tap on it. I don't know why it's being dumb. But you can just tap on it and it'll find the point. Like to find the x-intercept, it's finding it just like that. There's the x-intercept. Like it's kind of showing it. If I go over here to it, it says right there. You can't see it. So it says the minimum is 3, -1. So let's do that with the other calculator. Square root of x minus 3 minus 1. Graph it, and it looks just like, well, kind of looks just like what we found on Desmos. Like I said at the beginning of, I don't know what you call this, class? Like what it said at the beginning of class, it looks almost the same. But the Desmos is more, I think, user-friendly. So to find the minimum, you do second calc, and it's a minimum. Got to move to the left. See, and it's gone because it's not over there. We can go to the right, and then we guess. What did I do? Oh, I didn't go far enough to the right. It's not going to find it for us. Okay, so there's another way to find. I think that might be why Desmos is being done too, because of the way this. Okay, so with a square root function, this moves it down 1. And this moves it to the right. So these numbers are your vertex. So if you look at the function.
I think I got it.
Yeah. If you look at the function, this point right there is our minimum, and you look at that, -3 would be over here. That's actually +3. It's the opposite of this, always. 3, -1. Okay, that is the ordered pair for the vertex. We actually spend a lot of time on a square root function later on. So this is +3 and -1. 3, -1. So the domain, does anybody have any ideas?
Is it 3 to infinity?
The domain is 3 to infinity. Good, Nathan. Okay, do I do bracket or do I do parentheses?
Parentheses.
Bracket. It's a bracket.
Okay.
Okay, and the way that you can tell whether or not to use a bracket is I can put this number, 3, into the function square root of x minus 3 minus 1. And if I put 3 in, 3 minus 3 square rooted is just 0, -1, and it gives me the y value. That means I can do a bracket for the -1 in the domain, or in the range, I mean. So if I put a number that I couldn't do, like if I put -4, or let's do 2. 2 minus 3 square rooted minus 1. 2 minus 3 is -1. Square root of -1 is imaginary, so it's not on our graph. It explodes. It's bad. Okay? So that's how you can know if you can have it or not, is if it makes it imaginary. Makes it explode. Makes it jump off of your graph. Okay, so that's our domain. Somebody but Nathan. Brooke. Brooke, what's the range? You there, Brooke? Any idea, Brooke? Somebody want to help Brooke out? Brooke's not here? Awesome. How about... Oh. Now I got 2 Brooks. Brooks having technical difficulties.
Okay, sorry, my microphone wasn't working.
You're totally
fine. Is it
fine.
-1 to infinity?
Very good. That's exactly right. Do I put a bracket on -1 or do I put a parenthesis on -1?
Bracket.
Bracket. Exactly right. Okay. Does anybody have any more questions? Are you guys all solid? That is how to do domain and range. I'm going to do this every day, you guys. You don't have to be here every day. I will do starters that will be worth extra credit on the tests every day. So tomorrow I'm not going to do, well, we might do, because we did started 9.1 yesterday. I probably actually will do 9.2. Tomorrow we're a little bit behind, my fault because of the technical crap that I'm going through. But yeah, so tomorrow we'll do 9.2. I will post this video. Does anybody have any questions?
Can you do the bell ringer and then leave after?
Yeah, you could. I wouldn't though. This unit is, like last unit was pretty tough, and this unit is harder than last unit. This unit is really hard. I would stick around. Or I guess you could leave and watch the video. That would be fine. I hope that tomorrow's video won't be so long. But yeah, good luck you guys. Hope you're enjoying your isolation, your social distancing. Thanks, you guys. I'll be here tomorrow, 9 o'clock again.